everyone, we're going to verify this trig identity, and we should end up with a squared plus b squared. So we're trying to make the left-hand side look like the right-hand side. We're basically going to be using our Pythagorean identities here and these two factoring facts here. So we're going to expand this one based off this, because this has the form a plus b squared. So when you do that, you're going to get, you take your a. In our case, the first part, our a is a sine theta. So that's going to be a squared sine squared theta. Then we're going to do the 2ab. So this is going to be plus 2ab. And then we still have sine of theta, cosine of theta. And then for the this part, we do the same thing as we did with sine. It's just b squared cosine squared of theta. Now, we do the same thing for this one. The only difference is it has a minus. So we're going to have a squared plus, because there's a plus here, a squared cosine squared of theta, minus 2ab cosine theta sine theta, all right, plus b squared sine squared of theta. Now these two are the same. They just rearranged that. So those are the same, and they're going to simplify there. So now what we have is a squared sine squared of theta plus b squared cosine squared of theta plus a squared cosine squared of theta plus b squared sine squared of theta. Now, what we're going to do is pull out our a squares. So if I'm going to factor out a squared first, I'm going to get a squared times sine squared theta plus cosine squared theta. So I did that part, and then do the b squares. Factor out b squared. When you factor that out, you're going to get cosine squared theta plus sine squared theta. Now, back to our Pythagorean identity. This equals 1, so you have a squared times 1 plus b squared, that equals 1, times 1 equals a squared plus b squared. And we verified the trig identity. Thank you. Have a nice day. Bye-bye.